Hello there and welcome to this lesson on substitution. So substitution's a pretty cool method that you can use to help you simplify, to reduce the number of variables in multiple equations and then be able to actually solve, which is what we'll use it for here, is to solve and to find out what are the points of intersections in a linear system. So let's say we're given a question here, solve the linear system. In this question, we've got two equations, both linear equations, and we need to solve for that point of intersection. So first things first, we can label our equations 1 and 2. I like to do that as well. Once you have them labeled, we are essentially going to substitute 1 into 2. All right, so right now equation 1 is y equals 3x. That is what y is equal to. So wherever we see a y in equation number 2, we can essentially substitute in that 3x. Hence why it's called substitution method. So where we see a y in equation 2, which is y equals, we're going to put 3x instead of that, and we still have equals, and the rest of that equation there, x plus 4. Now we have actually gotten rid of the y variable altogether, and we can solve for what x is equal to in this instance here. So to do that, we can start by collecting like terms. We'll move that x term over from the right side of the equation to the left. It's going to become negative, so it's going to leave us with 2x is equal to 4. And if we divide by 2, x is going to be equal to 2. Now that we know what that x coordinate is, we can sub x equals 2 back into either equation 1 or equation 2, whichever you think is easiest to solve for. They're both fairly easy in this case here. I'll sub it back in for equation 1. So y is going to be equal to 3 times 2. Y is going to be equal to 6. You'd get the same answer if you subbed that value of x equals 2 into equation 2. So here now we have an x coordinate and we have a y coordinate. So we can go ahead and say, therefore, our point of intersection for these two equations will be 2, 6. Again, substitution is a really helpful method to actually be able to solve these algebraically, rather than if we were to, graph this out. Let's say here in this Cartesian plane up in the right-hand side here. If I was to graph this out, I have y equals 3x, so it's going to start here, and it's going to increase by 3 each time we move 1 to the right. So you get a line that looks something like that right there. And if we did the same thing for the second equation, y equals x plus 4, and we graph that, it's going to start at the y-intercept of 4 and go up by 1 each time we move to the right. So we get something like that. And you'd see right there, there's that point of intersection where those two lines meet, which is occurring at 2, 6. So that would be, prior to knowing substitution, graphing would be how you would actually solve for that point of intersection. And then once you learn substitution, you are actually able to algebraically solve for that point. Very, very helpful, and you'll use throughout your math careers. Let's do another example here. Solve this linear system. So again, we start off, we label our equations, equation 1 and equation 2, and then first thing you need to do if we are using substitution is we need to isolate for a variable. So step 1 is isolate for variable. It doesn't matter which variable you isolate for. You could isolate for y, you could isolate for x. You will ultimately get the same answer. So pick whichever variable is easiest to isolate for. Look for variables, or look for coefficients, those numbers that are in front of the variable. Look for coefficients of 1, because those are going to be easy to isolate for. So in this instance, that x variable has a coefficient of 1. in front of it, that's the one that I'm going to target and I'm going to isolate for. So if I wanted to rewrite equation 1, I could rewrite that as x is equal to 4 minus 2y. I now have the x term isolated on its own, and I can go ahead now and I can sub 1 into 2. And then I'll be able to solve for y. So wherever I see an x in equation number 2, I'm going to sub in 4 minus 2y. So I have in my new equation, I'm going to do substitution here, 3y minus 6. I see an x right there, so I'm going to sub in what x is equal to, what we just isolated for, which is 4 minus 2y is equal to -9. And now I'm going to start to solve for y. I'm going to need to distribute that 6, which is negative, into the brackets, so watch your minus signs. 3y minus, so -6 times 4 is going to be -24. -6 times -2y is going to be plus 12y is equal to -9. And now start to collect like terms. 3y plus the 12y will give me 15y. And then if I move the 24 over onto the right-hand side of the equation, it will be -9 plus 24, which is going to leave me with 15. And then if I divide by 15 on either side to get y by itself, y is going to be equal to 1. And now I can take that answer of y is equal to 1, and I can sub that into equation number 1. That equation right there that I just isolated already for x. You can sub it into the original equation if you wanted to. You can sub it into equation 2. They should all give you the same answer, so I recommend choosing the one that's easiest. In this case, it is the one that has x isolated already on its own. So if I do that, x is equal to 4 minus 2 times y, which was equal to 1. So x is equal to 4 minus 2. X is equal to 2. And then we will list our answer as an ordered pair. Therefore, point of intersection is 2 and 1. So at that point, 2, 1 on a graph, these two lines would be intersecting with one another. All right, we'll do one more example here. This one involves a little bit of distributing. So in this case here, we have solve each linear system. It doesn't look as familiar to us as what the previous questions sort of looked like, but regardless, all we need to do first is start off by simplifying each of these equations and distributing into the brackets appropriately. So if we do that, we can rewrite equation 1 as 4x minus 4 plus 2y plus 8 equals 16. And we can rewrite the second equation now as 5x plus 10 minus 3y plus 3. Negative times a negative is going to give us a positive, is equal to 50. And now let's just go ahead and let's clean up both of these equations here. So if I rewrite that first equation when collecting like terms, I will get 4x plus 2y. All right, this is this equation now written right down here. All right, I get 4x plus 2y, and then I'm also going to be collecting like terms for the constants here. I'll move them all over to the right-hand side of the equal sign, so I will get 16 minus 8, which is going to give me 8 plus 4 then will give me 12. And there is my new equation 1. And now for equation number 2, I will rewrite that as well. Once I collect like terms, we have 5x minus 3y is equal to, and now I will collect the constants on the right-hand side of the equation. It'll be 50 minus 10, which is 40, minus 3, which is going to be 37. All right, so at this time here, now if we're using substitution, and we are trying to isolate for one of the variables, and we're trying to choose which one to isolate for here. None of them have a coefficient of 1, but we can actually divide each term in this equation here, equation 1, by 2, and then we would be able to isolate for y. So if we were going to rewrite that equation after we divide by 2, it would become 2x plus y is equal to 6. And if we were isolating for y, we would get y equals 6 minus 2x. And now we can take this new equation right here that we've just generated, that we've isolated for y, and we can take that and we can sub into equation 2. Wherever we see a y, we're going to sub in 6 minus 2x. So we get 5x minus 3 times y, which is equal to 6 minus 2x is equal to 37. And now go ahead and simplify and solve for x. We're going to have 5x minus 3 times 6 is negative 18. Negative 3 times negative 2x is plus 6x is equal to 37. And if we go ahead and collect like terms, we are going to have 37 plus 18 on the right-hand side of our equation. That's going to give us 55. And 5x plus 6x is equal to 11x. And if we simplify that out, x is going to be equal to 5. So x is equal to 5. We can take that value and let's sub it right back into that equation that we are rearranged for right there. That's the easiest one. Y is already isolated in that equation. So let's go ahead and sub it in there. Y equals 6 minus 2x. And x we said is equal to 5. So y is equal to 6 minus 10. So y is equal to negative 4. And we say, therefore, our POI, our point of intersection, is 5, negative 4. All right? And a really cool way to also quickly check this is by performing a little left side, right side check. All right? So if we wanted to do that, make a little chart here, left side and right side, and we can just take the equation that we did not use to find that final answer. So we subbed it into equation 2. So let's use equation 1 here. Use equation 1. And we are going to write the left side of what that equation was. So if we take the left side of what equation 1 was, right there, underlined right there. If we take those values and rewrite 4x plus 2y, and on the right side of that equation was 12. If we write 12 right there, if we sub in our values for x and y that we just found with our point of intersection, we should get a case where left side equals right side. It lets us know we've done it correctly. So if we sub in for x a value of 5 plus 2, and then y was equal to negative 4, we see that this is going to be 20 minus 8. And we see that we have a case where the left side is equal to the right side. All right, and that is a fairly advanced substitution question right there. We've gone through several of them of different difficulties. And down the road, sort of where else you'll see substitution is that grade 11 functions, you'd see it. You'd be doing substitution elimination for a linear system and a quadratic as well, where you'd get 2 points of intersection, and you'll use it as well throughout your entire time in high school with advanced functions and solving systems of equations and calculus and vectors, where you're solving point of intersections involving 3 planes. So this is definitely a good base skill to have and to develop and to understand.